The universe, with its vast expanse and countless mysteries, often leaves us in awe. Yet, every so often, it throws a tantalizing discovery our way that rekindles our eternal quest to understand our place in the cosmos. Imagine a planet just slightly smaller than Earth nestled around a distant star, potentially warm enough to host liquid water, and maybe, just maybe, harbor life. What secrets does Gliese 12b hold, and could it be the key to unlocking the mysteries of habitability beyond our solar system? Astronomers have discovered Gliese 12b, an Earth-like exoplanet situated 40 light-years away. This discovery, made by two international teams of astronomers and published in the monthly notices of the Royal Astronomical Society, is particularly exciting because it opens a new chapter in our understanding of potentially habitable worlds. Orbiting a cool red dwarf star named Gliese 12 in the constellation Pisces, this exoplanet completes an orbit every 12.8 days. With a size comparable to Venus and an estimated surface temperature of 42 degrees Celsius, it stands out as one of the few exoplanets that could be temperate and possibly habitable. The significance of Gliese 12b lies in its potential atmosphere. If it possesses an atmosphere akin to Earth's, it could maintain temperatures conducive to liquid water, a fundamental requirement for life as we know it. On the other hand, if its atmosphere is more like Venus's, which underwent a runaway greenhouse effect turning it into an uninhabitable inferno, Gliese 12b might be less welcoming. The possibility of having no atmosphere or an entirely unique type of atmosphere also exists, making the next steps in its study crucial for understanding its true nature. Determining the atmosphere of Gliese 12b involves using the transit method. This technique, which has helped discover most of the 5,000-odd exoplanets confirmed so far, relies on observing the dip in brightness as a planet passes in front of its star from our viewpoint. During such a transit, the star's light passes through the exoplanet's atmosphere, allowing telescopes like NASA's James Webb Space Telescope to detect the specific wavelengths absorbed by various gas molecules. These chemical fingerprints can reveal the composition of Gliese 12b's atmosphere if it has one. The proximity of Gliese 12b to its host star, receiving about 1.6 times more energy than Earth does from the Sun, places it in a unique position. This energy difference means its surface temperature is highly dependent on its atmospheric conditions. With an equilibrium temperature of 42 degrees Celsius assuming no atmosphere, any actual atmospheric presence could significantly alter this temperature. This makes Gliese 12b an intriguing subject for further investigation, especially when compared to the average surface temperature of Earth, which is 15 degrees Celsius. Gliese 12b represents one of the best targets to study whether Earth-sized planets orbiting cool stars can retain their atmospheres, a crucial step to advance our understanding of habitability on planets across our galaxy, says Shashir Dalakia, a doctoral student at the Centre for Astrophysics at the University of Southern Queensland in Australia. Dalakia co-led the research with Larissa Palathorpe, a doctoral student at the University of Edinburgh and University College London. Their work, along with contributions from a team in Tokyo, has highlighted the potential of this exoplanet to bridge the gap of our knowledge between Earth and Venus. The discovery was made using observations from NASA's Transiting Exoplanet Survey satellite. We found the nearest transiting temperate Earth-sized world located to date, says Masayuki Kuzuhara, a project assistant professor at the Astrobiology Center in Tokyo. Kuzuhara co-led the research with Akihiko Fukuyi, a project assistant professor at the University of Tokyo. Although it's still unknown whether Gliese 12b possesses an atmosphere, the planet's size and the energy it receives from its star make it a prime candidate for study. Understanding the atmosphere of Gliese 12b could also shed light on the atmospheric retention of planets orbiting cool stars, which make up the majority of stars in the Milky Way. Red dwarfs, known for their magnetic activity and frequent X-ray flares, pose a challenge for the atmospheres of their orbiting planets. However, both research teams have found no signs of such extreme behavior from Gliese 12, raising hopes that Gliese 12b's atmosphere, if it exists, might still be intact. Atmospheres trap heat and, depending on the type, can change the actual surface temperature substantially, explains Dolakia. The equilibrium temperature quoted is based on the assumption of no atmosphere. but the actual conditions could vary significantly if an atmosphere is present. This variation makes Gliese 12b an important subject for understanding how different atmospheres influence planetary temperatures and habitability. Palathorpe adds, "It is thought that Earth's and Venus's first atmospheres were stripped away and then replenished by volcanic outgassing and bombardments from residual material in the solar system. The Earth is habitable, but Venus is not due to its complete loss of water. Because Gliese 12b is between Earth and Venus in temperature, its atmosphere could teach us a lot about the habitability pathways planets take as they develop." The importance of retaining an atmosphere is highlighted by the example of TRAPPIST-1 system, located about 40 light-years away from Earth, the same distance as Gliese 12b. The TRAPPIST-1 system consists of 7 Earth-sized planets, 3 of which are in the habitable zone. However, at least 2 of these planets, and likely all of them, have no atmosphere and are barren, dashing hopes that they could host life. This context underscores the excitement and potential of Gliese 12b's discovery. Michael McElwain, a research astrophysicist at NASA's Goddard Space Flight Center, emphasizes the need for more examples like Gliese 12b to better understand the diversity of atmospheres and evolutionary outcomes for planets. We know of only a handful of temperate planets similar to Earth that are both close enough to us and meet other criteria needed for this kind of study, called transmission spectroscopy, using current facilities. McElwain notes, Gliese 12b, with its unique position and potential atmospheric conditions, represents a significant step forward in our quest to find habitable worlds beyond our solar system. As researchers continue to study this exoplanet, it may reveal secrets that help us understand the delicate balance required for a planet to host life and how different factors influence the development of habitable conditions. The story of Gliese 12b is just beginning, and it promises to be an exciting journey into the unknown, expanding our horizons and deepening our understanding of the universe we call home.